So here are the solutions to our problem 3, our practice problem from the factoring lesson today. And they're just to give you a little more exposure to what factoring problems look like. If you'd like some more practice, I highly suggest you go to our textbook. The solutions to all the odd problems are in the back, and they go through all the different types of factoring problems. But let's look at the first one. In general, the first thing you want to do when you approach a factoring problem is look for a greatest common factor. In this first one, we see that we have 27, 9, and 9 as the coefficients. So we can factor out a 9 since 9 divides all three of those. We then find x to the 7th, x to the 6th, x to the 4th. So there's an x in every term, and we can factor out at least 4 of them. So we'll take out an x to the 4th. We also see a y in each term, so we can factor out a y. The z only appears in the last term, so that just stays there. When we factor out 9x to the 4th y, for the first term that leaves behind a 3x to the 3rd. The second term we have x squared, and the third term we have z. And that is our final answer. Notice the cubic we have left has 2 variables, and in general we're not going to give you problems that's going to be 2 variable cubic kind of things. So our final answer is 9x to the 4th y times the quantity 3x cubed plus x squared minus z. If you do see 2 variables like that, the only way that this will factor is if it has another greatest common factor, so if we missed one of the factors, or if we factor by grouping. We can't do either, which is why our solution for problem 1 is complete. So this method was the greatest common factor method. For problem 2, first we want to check for a greatest common factor. We cannot factor out any integers, because the coefficients are 1, 3, 3, and 1. We can't factor out any x's because they only appear in 3 of the 4 terms, and we can't factor out any y's because they only appear in 2 of the 4 terms. So there's no greatest common factor. If the greatest common factor does not work, then we're left with factoring by grouping, special factors, or factoring trinomials. Notice though, we have 4 terms. If you see 4 terms, chances are this is factor by grouping. And we will want to group these into groups of 2. To determine the groups, we look at our variables. We have 3 x's that appear and only 2 y's. So let's group those y terms together. We get 3xy plus 3y, and that leaves us with a grouping of x squared plus x. In each group, we want to now factor out the greatest common factor for that group. In the first group, we have a 3y, which leaves behind x plus 1. In the second group, we have x, leaving behind an x plus 1. Notice, both left behind an x plus 1, meaning we can now factor out x plus 1. That leaves behind 3y plus x. And there is your final answer. And this one was factor by grouping. The additional problems will be solved in the remaining videos. And if you're ready for problems 2 and 3, please go to the next video.